Hi everybody, this is a video about amortization tables or amortization charts, whichever way you prefer to say it. And the goal of this video is to show you how to build one of these tables given all of the loan information. So if somebody comes to you and they say the time of my loan is this, the loan amount was this, the interest rate is this, etc., you should be able to build a table for that loan. So a natural starting point, of course, is the question, what is an amortization table? And it's kind of hard to explain without having an example going, and we'll look at an example in a second. But essentially, an amortization table is simply a roadmap for the loan, for the life of the loan. So it's a table that spells out in explicit detail exactly what's going on with the loan at any particular time. So, for example, if you want to know how much you still owe the bank 3 years into your payments, the table will show that to you. So it essentially just encapsulates most of what you'd want to know about a loan into a table. So let's start with an example. So Jack takes out a 5-year car loan of 12 grand at an annual interest rate of 3.5%. He's going to pay back the loan in monthly payments. So the first thing we need to know is how much these payments are. How big are these monthly payments? And to actually calculate that is the topic of a different video. So for now, I'll just tell you. His payment is $218.30. So that's how much he has to pay the bank each month not to have his car repossessed. Okay, so let's start building a table. And so just to make sure this table fits on my screen, I abbreviate remaining balance as RB and portion to principal as PTP. So an amortization table looks like this. So the left-hand side is just keeping track of which payment you're on. So 1 just means first payment, 2 means second payment, 3 means third payment, etc. And so one thing to note here is Jack takes out a 5-year loan and he's going to pay them back in monthly payments. So 12 times 5 is 60. That means that he's going to make 60 payments. So this table actually has 60 rows. So there'll be a row, row 40 is for his 40th payment, for example. Now, of course, it is impractical to show all 60 rows on the screen. So for the rest of this video, I'm just going to show small little snippets of each amortization chart just to make sure that it fits. So we're going to fill out this table for Jack just for his first 3 payments. Now, once you can fill out the first 2 or 3 rows, you can fill out the rest of the rows. The procedure doesn't change as you move down the table. So if you can master filling in the first 2 or 3 rows, you can master filling in the entire table if you want to. Okay, so let's talk about what each of these columns mean. Payment amount simply means how much he's paying on the loan. And so if he's going to pay $218.30 every month, and let's just assume that for now, then that's the number that goes in here. This is literally the amount that he writes on a check when he goes to pay it at the bank every month. The interest column is keeping track of how much of each payment the bank is just pocketing as interest. Okay, so interest is just a fee that the bank charges you since they've loaned you this money. And so every time you write a check to the bank, they're going to keep some of that money as interest. And so this entry here is just going to keep track of how much of this check did the bank just pocket. So portion to principal, on the other hand, is the amount that the bank doesn't just pocket. It's the amount that they actually use towards paying down your loan. So this check for $218 will be broken into 2 pieces. One of the pieces doesn't do you any good. It's just money that the bank keeps. The other piece does do you some good. It goes towards paying down your loan. This final column here, the remaining balance column, that simply keeps track of how much you still owe the bank after each payment. So this entry down here in the bottom right, that's how much you still owe the bank after your first 3 payments. Okay, so that's what the columns mean. So let's talk about how you actually fill them in. So let's start in the most natural place. Let's ask ourselves, how much interest do I owe from my first payment? So when you write your first check to the bank, how much of that money will the bank simply keep, and how much of it will do you some good. To calculate interest, you just use the simple interest formula. So interest is PRT, but you have to keep track of exactly what these letters mean. So in the context of this particular loan, P means the amount that you still owe. It's the principal you still owe. R is the interest rate. T is time in years. So in this particular context, for your first payment, you still owe 12 grand. That's the principal. So that's what you plug in for P. The interest rate was 3.5%, so you have to convert that to decimal. You don't want to type 3.5 here. So here's 3.5% in decimal. Time, you have to be careful here. It's natural to write T equals 5 right here because the loan is 5 years long. But that's not what you want to type. So think about how this loan is working. The bank owes you money, or sorry, the bank loans you money, and then 1 month later you come back to pay them. They can't charge you for 5 years of interest because only 1 month has elapsed. Okay, it would be illegal for them to charge you 5 years of interest because 5 years hasn't gone by. So they're going to charge you for 1 month's worth of time and interest. And that's why it's 1/12 right here. 1/12 of a year. Okay, so for your first interest payment, you take the amount you owe, 12 grand, times the interest rate, times the amount of time that's elapsed, and you get $35. So you just fill in the number 35 here. Now, if you want to know how much goes to principal, well, whatever is left over from this check after the bank pockets the interest, that's how much goes to principal. So, yeah, so you want to know how much goes to principal. So this equation is always true. The amount that goes towards paying down your loan just is your payment amount minus the amount of interest they took out. So it's whatever's left over after they take out interest. So in this particular box up here, 218 is the payment amount. They kept $35. What's left over is $183.30. So that's what goes right there. Okay, so the remaining balance is how much you still owe on the loan. Well, the bank took this check and they kept $35 of it. The rest of it goes towards paying down your loan. So if you want to know how much you still owe, this equation is always true. The amount you still owe is the amount that you used to owe before the last payment minus the portion to principal. Okay, so I owed them 12 grand. I made this payment, and from this payment, they're going to use $183.30 to pay down the loan. So 12 grand, take away $183.30, that's how much I still owe. Okay, so let's just pause and look at this first row here. This was my first payment. That's what that one means. I paid $218.30. That's what this number is saying. Of that $218.30, $35 was kept as interest. It didn't do me any good. But of that $218.30, $183.30 was used to pay down my loan. And this is how much I still owe. Okay, so that's what it's telling you. So now when you move on to the second row, and you want to know how much interest do you owe now, you just repeat this process, making sure you interpret all the letters carefully. So again, here's our interest formula. Interest is principal times rate times time. And so in this case, the principal though isn't 12 grand anymore, right? You reduced that 12 grand down to 11,816.70. So that's how much you owe now. The bank can't charge you interest on any more than that because that's what you owe. So that is now the principal when you move down to your second payment. The interest rate has not changed. The time, you'll notice, is still 1/12. And so you might ask me, why isn't it 2/12, right? Because we're now 2 months into it. And the answer is, well, you've already paid interest on the first month. And so again, they can't charge you interest on a double time period. That would be illegal. They've already charged you interest on the first month. So the biggest time period they can charge you interest for now is the second month, which is just 1 month long. So here you go. Here's the new amount that you owe, times the interest rate, times the time that has elapsed since the last time they charged you interest, and the number you get is $34.47. So that's what goes there. Okay, so again, think about what's happened here. After the second month, you've cut them a check for $218.30. they now keep $34.47 of it, right, which is slightly less than what they kept from the first check. And so now whatever's left over is what goes to principal. So again, you take your payment amount, subtract off the amount the bank just kept as interest, and $183.83 is how much goes towards paying down your loan. So that's what goes here. Okay, and again, the remaining balance, well, currently you owe them $11,816.70, and $183.83 is going to paying down your loan. So you take the amount that you owe them, subtract off the amount that's going towards paying down your loan, and you end up with $11,632.87. So that's what goes there. Okay. So before we fill out the third row, let me just point out, when you're filling out the second row, you must take into account what happened in the first row, right? You're not using the number 12 grand anymore because you don't owe that anymore. You're using this number, 11,816.70. That determines how much goes to principal. That also determines the new remaining balance. Okay. So in all these calculations here, right, when we calculate the interest, we use the amount we currently owe when we make that second payment, right? The amount that we currently owe when we make that second payment. So you have to update your numbers as you go down through the table. And so here's just the rest of the table filled in. So when I calculate this interest here, $33.93, I would use this amount as my principal, this $11,632.87, because that's how much I owe when I make my third payment. And then I calculate my portion of principal and I take that number away from the $11,632.87, because again, the $11,632 number is what I currently owe when I make my third payment. And what I'm left with is $11,448.49. Okay, so before we move on, let's make some observations here. The first observation is what I mentioned at the beginning. This table continues for another 57 rows. It's just not practical to show them all, right? The screen would be too small. The second thing to note is that the amount of interest that you pay out of each check is going down. And it's going down because you owe less and less. So the amount of interest should be going down, and in fact, the amount you owe should be, the amount of interest should be speeding up. Sorry, I said that wrong. So notice that to go from 35 to 34.47, that's only 53 cents. To go from 34.47 down to 33.93, that's more than 53 cents. So you'll actually see the rate increasing, the rate of decrease here. The portion to principal is increasing. Okay, you're paying less interest every time, so the amount that's left over to pay down principal goes up. So the amount of interest that the bank keeps goes down, the amount that goes to principal goes up, the amount that you owe goes down. Right? You're eventually going to pay off this loan. So in row 60, somewhere down here at the bottom, there should be a 0 right here. You finally owe them nothing. So to reach a 0 down here, these numbers should be going down as well. Okay, so if you're making a table and you notice that these things don't happen, you've made a mistake. If the amount of interest goes up, for example, you've made a mistake. If the portion to principal goes down, you've made a mistake. Well, you've made a mistake, or there's something crazy with the interest rate going on or something. But anyway, something unreasonable is happening if that occurs. Okay, so let's talk about making these tables in modified situations. So one of the nice things about these tables is you can keep track of changes in the parameters of the loan. So here's one way that the parameters can change. So let me just remind you the question. It was 12 grand, 5 years, 3.5%, monthly payments like this. So suppose Jack, though, decides he wants to pay off the loan early. So instead of paying $218.30, he pays $250. And then after that payment, he decides, well, I can afford an extra $25 a month. So for his second payment and all other future payments, he pays $275. And you can do this, of course. The bank wants at minimum $218.30. You can pay them whatever you want beyond that. And you just have to tell them you want that money to go to principal, and it will. So Jack is paying an additional, what, $32 by paying $250 and then paying an additional $25 on top of that when he pays $275. So that's an additional chunk of money that's going to paying down principal. So how does this play out in the amortization table? Well, here's how the old table started, right? On the previous example, he paid $218.30 was his payment amount. But now his first payment is $250. His second payment is $275. His third payment is $275, etc. So if you were to make this chart farther down, you would just see 275s all the way down, because that's what the problem says happens. So that's different, right? He's paying more every month. But in terms of filling out the table, you now just do everything the same way. So I'll fill in the first row for you. So he goes to the bank and cuts them a check for $250. How much interest does he owe? Well, he owes them 12 grand. Interest rate is 35%. He's 1 month in, so he owes them $35. So the new interest for the first check is actually the same as the old interest. Right? He paid $35 the other time too. What's the new portion of principal? Well, he gave them a check for $250. They pocket $35 as interest, so what's left over now is $215. So the portion of principal is bigger here. And how much does he still owe on the loan? Well, they're going to take that $215 and apply it towards paying down his loan. So when you take 12 grand and take 215 away from it, you're left with 11,785. So here's a new first row for this new loan information. And so let me just remind you what the old first row was. The interest from that first check is actually the same. The portion of principal, though, now in red is much bigger. And that makes sense because the check that he wrote is much bigger. So this red number is bigger than the black number. And this red number here, for how much he still owes, that's smaller than the black number from the previous example. That also makes sense because more money is going towards paying down his loan. So he should owe less since he's paying more. Okay, so I just went in and filled in the rest of the table here. You can do this yourself. So if you want to know what this interest is right here, this 34.37, where did that come from? Well, it comes from the I equals PRT formula, where P is 11,785, because that's how much he currently owes when he makes that second payment. And where does this number come from, this portion of principal? Well, he wrote a check for $275. The bank kept $34.37 of that. What's left over is this $240.53. And actually, sorry, it should be $240.63. So that's a typo. Right, this plus this should equal $275. So in any case, 63. Okay, so this number is probably also off by 10 cents. But in any case, the idea is the same. You use how much he owes after the first payment to figure out the interest. You take that interest away from the payment amount to get your portion of principal. You then take the amount that you just owed, subtract this 240.53, and you get this number, etc. So the process is the same. And so again, let me just remind you what the original numbers were. So the first row we already discussed. In the second row, his interest now is smaller than his old interest. That makes sense because this red number here is smaller than this black number, so the amount of interest he owes on it will be smaller. And his payment's a lot more, so in the second row here, his portion of principal is quite a bit more than it used to be. And this 11,544.47 is much smaller than this black original number of 11,632.87. So what is the effect of him paying more every month? The effect is that he owes less interest every time. He gets more going to principal every time, and the amount that he owes falls much faster. So he will actually end up paying this loan off early, will be the effect. And if you constructed the table all the way down, you would see how early he pays it off. I think he pays it off in like 4 years and 2 months instead of 5 years or something. But in any case, you could just keep going and see what happens. So we will see how useful these are in other situations where maybe the interest rate changes. I guess that's the main other situation. But here you can see exactly what happens when he pays more than the minimum.